Hello everyone, welcome to my channel. In this video I have this integral to work on. It's the integral of sine to the power 4 of x times cosine to the power 3 of x dx. Basically a product of powers of sine and cosine. Now how we approach it is to look at the two powers. You identify the odd power, like 3 is an odd number, and then you work on this one. That one will be taken care of automatically. As follows. So you split that. Let me start by capturing the integral. So we have the integral of sine to the power 4 of x times cosine power 3 of x dx. So what I was saying is we work on the odd power. We split it as follows. This is the same as the integral of sine power 4 of x times cosine, check this, power 2 of x times cosine of x dx. Watch how I have I've broken down cosine to the power 3 of x to cosine squared of x times cosine of x. Now we are going to use a simple trig identity here that says sine squared of x plus cos squared of x. The answer is 1. And therefore I want to get rid of this. This means I must make cosine squared of x subject of formula. This is what I get. So that expression must come into that space. So that integral then changes as follows. It's the same as the integral of sine power 4 of x times, open brackets, 1 minus sine squared of x, and then we multiply by cosine of x dx. Nice. Now I'm going to distribute sine to the power 4 across the bracket there as follows. I'm going to keep this one out the way it is. This is the same as the integral of distributing there, you'll agree with me, and maintaining the square brackets. We have sine to the power 4 of x minus sine power 6 of x, and then we have cosine of x dx. I hope you can follow what I'm trying to do there. Next, I'm going to distribute cos x dx and the integral as follows. So this is the same as the integral of cos, first of all, sine power 4 of x, and then I'm going to have cos of x dx. There's a minus sign there, minus the integral of sine power 6 of x times cosine of x dx. Nice. At this point, as you can see, we're now going to use u substitution as follows, taking us to the next page and to just finish this off now. U substitution comes in handy now. Let me move this one down. Right, so basically I'm now saying that that integral, these two integrals that you see, will change as follows. I'm going to use u substitution. I'll let u be equal to sine x. Du dx, you'll agree with me that this is just cosine of x. Derivative of sine is cosine. Multiply both sides by dx. Du is equal to cos x dx. Now watch, this is exactly that expression and that expression over there, as you can see. That means that integral changes as follows. It will be the same as the integral of u to the power 4 du minus the integral of u power 6 du. Now using power rule, you know that this is just u power 5 all over 5. We add 1 and divide, minus u power 7 all over 7, and then we have to say plus c as our constant of integration, c being a real number. Now what is u? Well, if you check here, u is just sine of x. So therefore our final solution is going to be 1 over 5 sine the power 5 of x minus 1 over 7 sine to the power 7 of x plus c. This is the final solution to the integral. Let me show you the integral we have been working on in this video. It's this integral here. Remember, sine has an even power, cosine has an odd power, and I said you work on the odd power. Now in the next video, I'm going to look at what happens if the even power is here and the odd power is there. And let me just show you the video, the integral I'm going to be working on in the next video. Here it is. See what I was saying? Compare this with this integral here. Compare this integral with this one. This is the one we have been working on. Sine has a power of 4, cosine has a power of 3. Now I swapped these. In our next video, I'm going to look at this one. Remember what I told you? You work on the odd power. So here we'll start working on that. I'm going to break this one down into sine squared of x times sine x and then carry on with that. All right, I am going to stop here. Tell me what you think about this integral. What approach would you have taken to arrive at the solution? Remember, the integral we've been looking at is this one. And the final solution, just to give you a short summary, that's the final solution to this integral. Right, I'm going to stop here. I'll see you in the next one.